This video is about solving geometric problems involving position vectors. Position vectors are vectors giving the position of a point relative to a fixed origin. So if O to A is equal to AI plus BJ, then the position vector of A is the column vector AB. So that means you've gone A across this way and B across this way. So A has position vector AB. So it's relative to the origin. If I want to work out A to B here, it's the same thing as going from A to O plus O to B, which is the same thing as negative O to A plus O to B. I can rewrite that as O to B take away O to A. So it's the same thing as if I know what B is, the column vector B, take away the column vector A, where O to A and O to B are position vectors of A and B respectively. Okay, so let's do some questions on this. Okay, so O to A is equal to 5i minus 2j, so 5 minus 2. I prefer to in them in column vectors, so I rewrite them in column vectors. And A to B is equal to 3i plus 4j, so as a column vector is 3, 4. If I want to draw a diagram, then if I have O here, A there, then O to A is 5 minus 2, and A to B is equal to 3, 4. Okay, find the position vector of B. The position vector of B means O to B. So remember, position vector of B is relative to the fixed origin. So it's the same thing as O to B, which is equal to O to A plus A to B, which is equal to 5 minus 2 plus 3, 4, which is equal to 8, 2. Part B, the exact value of the magnitude of O to B in simplified third form. So O to B is equal to the magnitude of 8, the column vector 8, 2, which is square root of 8 squared plus 2 squared, which is square root of 64 plus 4, which is square root of 68, which is equal to 4 times 17, so 2 root 17. Next question. The points A and B have position vectors A and B. So position vector means starting from the origin to A has position vector A. Origin to B has position vector B. The point P divides AB in the ratio 1 to 5. So undo. If I have A to B, P is somewhere where it divides A to B in the ratio 1 to 5. Find in terms of A to B position vector of P. So O to P, position vector of P means O to P, which is equal to O to A plus A to P. Now O to A is just A, but A to P will be a sixth of A to B. So I need to work out A to B first. So A to B is equal to A to O plus O to B, which is equal to negative A plus B. So it's the same thing as A plus a sixth of negative A plus B. So I end up getting A minus 1/6 A, which is equal to 5/6 A, and then plus a 6 B. So that would be my final answer. OABCD is a regular hexagon. So O, just start with O here, and AB, because you have to write it in the correct order. So A, I'm going to go clockwise, is OABCDE, like so. The points A and B have position vector A and B. So O to A is A, and O to B is B. Okay, where O is the origin, find in terms of A and B the position vectors of C, D, and E. So the first thing I'll work out is, I know if this is A, then E to B, because it's a regular hexagon, E to B will be double of O to A. So this will be 2A, 2 lots of A. Because obviously if it's a regular hexagon, it's going to be double O to A. Okay, A to B is equal to A to O plus O to B, which is equal to minus A plus B. Okay, so I know this is minus A plus A to B is equal to minus A plus B, but also that is the same thing as E to D because they're the same. And O to E is equal to O to B plus B to E. O to B is B, and B to E is minus 2A. Okay, so if I want to work out everything, so first thing is I want to work out the position vector of C, so that means O to C. So O to C is the same thing as O to E plus E to D plus D to C. O to E is B minus 2A plus E to D is the same thing as A to B, so it's minus A plus B plus D to C is just A. So you get minus 3A plus A, which is minus 2A. And you got B plus B, which is 2B. So minus 2A plus 2B. Don't forget O to E is the same thing as B to C. I'm just going to write it down here as well. That is obviously A, so on. Okay, B is position vector of D. So O to D, I want to go from O to D, it's the same thing as O to E plus E to D. O to E is, we worked it out already, is B minus 2A. And E to D is the same thing as A to B, so it's going to be minus A plus B. So we end up getting minus 3A plus 2B. Last one is O to E. O to E we've already worked out. For my working out over there, you know it's going to be O to B plus B to E, which is equal to minus B, sorry, it's B minus 2A. B minus 2A, which is the same thing as minus 2A plus B. The position vectors of 3 vertices of a parallelogram are 4, 2, 3, 5, and 8, 6. Find the possible position vectors of the 4th vertex. And for this one, because there's going to be more than one solution, I'm going to roughly sketch this out in order to help me to find the solution. So it says my first vertex is 4, 2. So I'm just going to go 4 across 2 up approximately. So this is 4, 2. 3, 5 will be somewhere here. So let's call this 3, 5. And 8, 6 will be somewhere here, roughly. So it's 8, 6. Now that means if I were to think about where my vertex could be, to make the first parallelogram, it could go there. So I get this parallelogram. But it could also be here. So I get this parallelogram. And it can also be, the other solution could be that it's somewhere here, so you get this answer. So there's 3 different solutions. Okay, so let's work out the red one first. So to work out the red one, I need to work out what this is. So if I go from 3 to 4, I'm increasing it by 1. If I go from 5 to 2, I'm decreasing it by 3. So from 8 to 6, to get to this point here, which is the point I'm trying to find, I need to decrease the I component by y, so increase the y component by y, and decrease the j component by 3. So I end up getting 8 plus 1, which is 9, and 6 take away 3 is 3. So 9, 3 is a solution. So 8, 6 plus 1 minus 3 is equal to 9, 3 is a possible position. Vector of the 4th vertex. So if I do something similar for the green one. So for the green one, what I need to work out is, so I've already worked out this. So if I'm going to go backwards, it means it's going to be -1 and +3. So if I want to work out this one, I need to -1 from the I component and add 3, which means this point will be 8 take 1 is 7, and 6 add 3 is 9. So 7, 9 is the other possibility. So it's going to be 8, 6 plus -1, 3 gives me 7, 9 is another possible solution. And the last one is a blue one I need to work out. So if I want to work out the blue one, so I need to work out what this is first in order to work out what this would be. So 8 goes down to 4, so it's -4, and 6 goes down to 2, which is 8 goes down to, 4, which is -4, and 6 goes down to 2, which is -4. So I need to do from 3, 5, I need to subtract 4 and subtract 4 from the I and j component. So I get 3 take away 4 is -1, and 5 take away 4 is 1. So -1, 1 is the last solution. So that is from the point 3, 5, I need to add -4, -4. So I end up getting -1, 1 is the last possible solution. The point A lies in a circle with equation x squared plus y squared is equal to 9. Given that, so that means, if I'm drawing it, the circle has center origin O at the origin, and because it's the radius squared is 9, that means the radius of the circle is 3. Given that OA, so O to A is equal to 2k and k, find the exact value of k. So A lies somewhere, can be anywhere, we don't know where it is, somewhere, and obviously it's equal to 2k, k. So what we do know is that the magnitude, because obviously the magnitude is the length, so what we do know is the magnitude of O to A is equal to 3, which means the magnitude of 2k, k is equal to 3. So that means the square root of 2k squared plus k squared is equal to 3. To get rid of the square root, we might as well square both sides. So we end up getting 2k squared, which is 4k squared plus k squared is equal to 9, which means 5 squared is equal to 9. So k squared is equal to 9 over 5. So k is equal to plus or minus root of 9 over 5, which means it's equal to plus or minus 3 over root 5, and we just need to rationalize it, which means k is equal to plus or minus 3 root 5 over 5. Relative to a fixed origin O, the point A has position vector 2, 3, minus 4, and position B has vector point B has position vector 4, minus 2, and 3. So if I were to draw this out, we've got the origin, we've got A, this is 2, 3, minus 4, and 2B is equal to, B is equal to 4 minus 2, 3. D is a point such that AB is equal to BD. Find the position vector of D. So what I know is, first thing I need to work out is A to B. So A to B is equal to A to O plus O to B. A to O is in the opposite direction, so it's going to be minus 2, minus 3, 4, plus 4, minus 2, 3, which means I end up getting 2, minus 5, and 7. So A to B is 2, minus 5, and 7. So A to B is equal to B to D. So that means, so if I have D, I need to add on 2, minus 5, 7 to get from B to D. So if I want to work out the position vector of O to D, so O to D will be equal to O to B plus B to D, which is equal to 4 minus 2, 3, plus 2 minus 5, 7, which is the same thing as, when I simplify it, 6 minus 7 and 10. And if I want to write an ijk component, is 6i minus 7j plus 10k. OABC is a parallelogram. P is the point where the diagonals OB and AC intersect. The vectors A and C are equal to O to A. So O to A is A and O to C is C respectively. So O to C is C, which means A to B is also C and C to B is also A because it's a parallelogram. Prove that the diagonals bisect each other. So what we need to do is find two different pathways from O to P. Now from O to P you can either go O to A and then A to P. So that's one way of going from O to P. Yeah. So O to P is equal to O to A plus A to P, which is equal to O to A plus, because A to P lies on A to C, lambda times a scalar multiple of A to C, because we don't know where P is on the line. So lambda times A to C, since P lies on A to C. So we need to work out what A to C is. So A to C is equal to A to O plus O to C, which is equal to negative A plus C. Therefore, O to A is A plus lambda times A to C becomes negative A plus C, which means if we equate the components A and C, we end up getting 1 minus lambda times A plus lambda times C. So that is our equation 1. So one way to go from O to P. Now a different way to go from O to P, if I do it in green, is O to B, just going straight from O to P, sorry. Just going from O, that's another way to get from O to P. But similarly, O to P is also equal to, because OP lies on O to B, some mu times O to B, since P lies on O to B. But O to B is equal to O to C plus C to B, which is just C plus A, which can be rewritten as A plus C. So it can be written as mu times O to B, which is just mu times A plus C, which is equal to mu A plus mu C. And this is equation 2. If we equate A and C for both 1 and 2, equation 1 and 2, we end up getting 1 minus lambda is equal to mu for A component, and for the C component we get lambda is equal to mu, which both implies that 1 minus lambda must be equal to lambda, which means 1 is equal to 2 lambda, which all implies that lambda is equal to half, which means mu must also be equal to half. So I have to write my explanation up. So therefore P is halfway between O to B and A to C. Therefore, midpoint of both diagonals, therefore diagonals bisect each other. And that would be the end of the proof. A different version of a similar question. OABC is a parallelogram. O to A is equal to A and O to C is equal to C. P is the midpoint of A to C. So part 1, A. Find the following in terms of A and C, simplifying your answer. So A to C is equal to A to O plus O to C, which is equal to negative A plus C. Part B is O to P is equal to, because P is midpoint of AC, it's the same thing as O to A plus A to P, which is equal to O to A, because P is the midpoint of A to C, must be half of A to C. Now O to A is just A, half of A to C is what we worked out previously, which is minus A plus C, which means if we simplify it, we get half A plus half C. Okay, part 2. Hence prove that the diagonals of a parallelogram bisect one another. Okay, so what I need to work out is O to B. O to B is equal to A plus C. O to P is equal to, we worked this out already, half of A plus half of C, which we can factorize to half times A plus C, which is equal to half of O to B. Therefore, P is the midpoint of O to B, or OB. Therefore, P is the midpoint of both diagonals of the parallelogram. Therefore, diagonals of a parallelogram bisect one another. So as soon as you prove there's a midpoint, both are midpoints, then they obviously bisect. Okay, last question I'll go through. The point A has position vector I minus 2j. So A is equal to 1 minus 2. The point B is such that magnitude of O to B is equal to magnitude of OA, and OB is perpendicular to OA. Part 1. A. Find the magnitude of O to B. So the magnitude of O to B is the same thing as the magnitude of O to A, which is the magnitude of 1 minus 2, which is equal to 1 squared plus minus 2 squared square rooted, which gives you square root of 5. So therefore, O to B, magnitude of that is equal to square root of 5. Okay, find the two possible directions of O to B, giving your answer correct to the nearest decimal place. So if I were to sketch this out, then we've got A is equal to 1 minus 2. There's 1 across minus 2. So this is A. So it says that O to B is perpendicular to O to A. So B will be somewhere here. B. So this A was 1 minus 2. So remember, then it's gonna then B will be either 2 across 1 up. So the possible value of B is 2, 1, because it's, remember, making right angle. It's right angle to A, or it will be here, which is minus 2 minus 1. Therefore, O to B is either equal to 2, 1, which means, therefore, theta, if you're working out theta, then theta because we've got, it goes across by 2 up by 1, then theta will be equal to tan of theta will be equal to a half. So theta is equal to inverse tan of a half, which is equal to 27 degrees, because we're trying to find the direction of O to B, okay? So that means the angle it makes with the positive x-axis. Okay, if O to B is equal to minus 2 minus 1, then we have to do 180 plus this angle, let's call it x, yeah? So we know tan of x, again, it's 2 and 1. So tan theta is equal to half still. So tan x, I should say x because we've labeled it as x. So x will be equal to inverse tan of a half, which was worked out is 27 degrees. So the direction will be equal to 180, because it's the positive x-axis, 180 plus x. 180 plus x, which is equal to 207 degrees. Find the maximum and minimum value of O to C. Sorry, the point C is such that A to C is equal to 2. Okay, remember this is root 5. So O to A is root 5. Sorry, I forgot to, let me just... So the point C is such that A to C is equal to 2. Now 2 is less than root 5. So that means from C, change it to red, we're drawing a circle of radius 2. So that's radius 2, yeah? Okay, find the maximum and minimum value of O to C. Now O to C will be the maximum when it's here, and will be minimum when it's here. Okay, so the maximum value of O to C will be equal to O to A plus the radius of the circle plus 2, which is equal to root 5 plus 2, because you have to go all the way O to A and then plus this radius, which is 2, yeah? Minimum value of C, minimum value of O to C will be equal to O to A minus 2, because what we're doing is for that one, O to A is the whole thing, but we need to take off the radius because we only want this part. So it'll be root 5 take away 2. So if we were to draw it out again neatly, just so you can see it properly. So A was here, which was 1 minus 2. We're drawing a circle of radius 2, which is less than. Then we're saying the maximum value of O to C will be here, which is going to be root 5 plus C. So C could be there, or the minimum value would be when it's here. So minimum value is when it's here, so it's going to be root 5. It's going to be this part only, which is root 5 take away the radius, which is 2.